Good morning, guys. Welcome to the lesson. Okay, let's go on. And the last lesson, my wireless was very bad. That's why uh, we canceled our lesson. Now let's go on. And negative indices. At the beginning of this unit, you read that negative numbers can also be used as indice. But what does it mean if an index is negative? If you remember, in the 8th grade or in 7th grade, the unit of exponential numbers or powers we had learned already. For example, negative indice. It means the a power of -1 or a power of -b. Okay, so a and b is real numbers, and a is called base, and b is negative power or index. So you can write it index. And how can we change the sign of our index? So it's the first way is there we have just a real number of a. For example, a is equal to 2. Okay, so 2 power of -3, and b is equal to -3. So how can we change the sign of the index? As you know, the under of 2 is our denominator. It's called 1. The second one, and the numerator is 2. And if we will change their places, and automatically the sign of indices also their signs are changing. And 1 over 2 in a bracket and a power of 3, and is equal to, it's accompanied also to 1 is 3, and including also for 2 is 1 cube is equal to, when you open the brackets, 1 over 3, or 1 cube over 2 power of 3, or 2 cube is equal to is 1 over 2 power of 3, or 2 cube is 8. Okay, so end of this example, you can write it, the a power of -b is equal to 1 over a in a bracket and plus b. And when you open the brackets, 1 power of b is also 1 over a power of b. So answer is 1 over a power of b. And look at the two methods of working out x cubed divided by x5, x power of 5 below. So there we have two methods of the solutions, the first method and the second method. The second and the first. This one is first. So using expanded notation, how can I expand x power of 3? You can write x times x times x. And or how can I write the x power of 5? 5 times x. 4 and 5. Okay. Now in a fractional number, we know if the numerator and denominator are the same, you can simplify that numbers one by one, x canceling, and simplify the second one and last one. So there we have just 1. There is we have x times x is x squared. So answer is 1 over x squared. And the second method, using the law of indice for division. If you know, if our base are same and in division, what can we do with powers? Exactly, just subtract. Or so base are same x and x, and into the middle of this operation there we have division. And what about the indice or powers? Exactly, we'll subtract the first power and the second power. So x power of 3 minus 5 and is equal to x power of -2. So as you know, just a moment ago, I showed you 1 over x squared means x power of -2, because of when you change the sign of 2 or sign of power, you will write 1 over x power of 2 or x or square. 1 square over x square. 1 square means just 1. So 1 over x squared is equal to x power of -2. Is clear? I mean, I hope it's clear for you. And this shows that 1 over x squared is equal to x power of minus 2. And this gives you a rule for working with negative indices. And shortly, we can write it x power of minus m is equal to 1 over x power of m. And exactly x not is equal to 0. So, and when an expression contains negative indices, you apply the same laws for other indices to simplify it. And 4 power of minus 2 is equal to 1 over 4 square, or just 16. Okay, and so the next exercise, 5 power of minus 1. 5 power of minus 1 is equal to, we should change our sign of indice, and that's why we'll change our denominator and numerator, or 5 power of 1 and is equal to 1 power of 1 over 5. And x power of minus 4, x power of minus 4 also 1 over x power of 4. And y power of minus 3 is 1 over y cubed, blah blah. And the next page, simplify, give your answer with the positive indice. So the first exercise, you can see the fractional number is given 4x squared or 2x power of 4. First of all, let me check of coefficients of variables is 4 and 2. We'll simplify these two coefficients and I will get 2. And x power of 2, x power of 4 means is 1 times 1 exactly, or x power of 2. So the answer is 2 over x power of 2, or x squared. So in the question, there's given us, we need the positive indice. The answer is 2 over x power of minus 2, or 2 squared. So and the next one, 2x squared minus square times 3 times x power of 4. Okay, solve this exercise. Okay. And B, 2x power of minus 2 and times 3x power of minus 4. We need the positive indice. That's why. Let's first of all multiply the coefficients. 2 times 3 is 6. And then as we have into the middle of the sign of multiplication, that's why the bases are same. And we will add the powers, and then x minus 6. And how it's compared just to x, that's why I need change with the denominator and to x. So that 6 is constant number, is staying in the same place, 6 over x power of plus 6. Okay. And the last one, power of power. Let's remind you what is the power of power. A power of B, power of C. So what was the operation? Just open the bracket and multiply powers. So n is equal to A power of B times C. Okay. And 3 times y squared in a bracket, and the power is minus 3. That's why minus 3 is, you can multiply, or you can take the 3 cube, and we will multiply the power and 2 and minus 3. So 3 power of minus 3 times and y squared times minus 3, and is equal to, what is the 3 power of minus 3? You will change the place of denominator, 1 over plus 3 cubed, and times, what about variable of y? Also, first of all, let's multiply the powers. 2 times 3 is minus 6, and you can write the place of this expression just y power of minus 6. And how can it change the sign of the powers? Exactly 1 over y power of 6. Okay, so n is equal to 1 times 1 is 1, and 3 cube is 27 times y power of 6. The answer is 1 over 27 times y power of 6. And as you see also in answer, found it the same answer. Oh, let's say the first exercise is not difficult. 4 power of minus 1 is equal to you'll change it just places 1 over 4. Okay, and the next one is 3 power of minus 1, 1 over 3, and 1 over 8. And different powers, for example, 5 power of minus 3. Also, you will write in a fractional number 5 power of 3 or 1 cube. It's the same, you'll get the same answer, 1 over 125. And then f 2 power of minus 5 is equal to 1 over 2 power of 5. So you'll get you will open the bracket, is 1 power of 5 is 1 over 2 power of 5 is 16 and 32. The answer is 1 over 32. Okay, state whether it was following are true or false. In the first question, 4 power of minus 2 is 1 over 16 is equal to x. Yes, is correct. And the next one, 8 power of minus 2 is equal to 1 over, it must be 64. It's not as 16, that's why it's false. And the next one, 1 over not 3x, just 1 over x power of 3 or x cubed is also false. And the last one, 1 over not x, but 2 over x squared is also false. And write each expression so it has only positive indice. And I want to show C. C is minus 2 is contained also x and y. That's why if you open the bracket, you will get x power of minus 2 times y power of minus y. Sorry. So sorry, it's minus 2. Or directly, you'll change the places. So what we'll get, it's 1 over x squared times 1 over y squared. Shortly, if you write x y power of plus 2. And h, the last one, 12x cubed times y power of minus 4. So how can I change the sign of powers? Minus 3 is not included for 12. That's why 12 is staying the same place. But the x is automatically changing 1 over x cubed plus cube, exactly 1 over y power of 4. So answer is 12 times 1 is 12 times 1 is also 12 over x cubed y 4. Okay. And simplify, write the answer using only positive indice. It's your turn. If you want to check yourself, please check it. And if you want to send me your answer, is also okay. And a summary of index laws. Shortly, if you want to, what we'll learn in this unit. If when multiplying the terms, you will add the powers if our base are same. So x power of m times x power of n is equal to x power of m plus n. And when dividing, subtract the indice. So into the middle of this x is the division. You will subtract the powers. And power of power, when finding the power of power, multiply the indice. So there's we have two indices, m and n. You will multiply just m times n, x power of m times n. And any value of to the power 0 is equal to 1. Is any value. Just you cannot take 0. X is element of real numbers. Just x not must be equal to 0 because of x power of x is undefined. That's why you cannot take 0. And x power of minus m is equal to 1 over x power of m also when x is not equal to 0. Okay. And fractional indice. The laws of indice also apply when the index is a fraction. Look at these examples carefully to see what fractional indice means in algebra. So if you know x power of 1 over 2 means in algebra, how can you write it in a just, how can I say, easily expression? How can I write it? So it means in a mathematic in square root of just x because of if you open the root, how can write it is equal to, yes, 1 over 2. So x power of 1 over 2 means in square root of x. So the square of root is 2 here, and the power of x is 1. So the power of root is goes to denominator, and the power of x, variable of power of variable, is going to numerator. So x power of 1 over 2. In other words, for example, 2 power of 3 over 2, or 2 power of 3 over 2. Okay, how can write it? In square root 2 power of 3 or 8. In square root is 8, right? Yes, 2 power of 3 is 8. Or in other words, 7 power of 1 over 3 in cube root 7. Okay, so the laws of indice in algebra, yes, we had already read it. And x power of 1 over 2 times x power of 1 over 2 is equal to x power of 1 over 2 plus 1 over 2 is equal to x power of 2 over 2 means x power of 1 over x. And use the law of indice, add the powers. Okay, 1 over 2 plus 1 over 2 is equal to 1, and x power of 1 means just x. In order to understand what x power of 2 means, ask yourself what number multiplied by itself will give x. So in square root, x times in square root is equal to, the powers are the same, a power of roots also same, is square, and base also same, is not important. Just x times x, you will get in square root of x squared, and you simplify with power of x and roots, and you will get just x. Fractional indice, the laws of indice also, yes, it's the same page. And next one is 1 over 3, yes, the same. Y power of 1 over 3 times 1 over 3 times 1 over 3. If you add the powers, you will get just 1, or y power of 1 is equal to y. And you will multiply the 3y in cube root y, you will get just y. Okay, rewrite using root signs. Is 1 over 5, yes. 1 over, if then in question is given y power of 1 over 5 means, what was the 5 or denominator? Exactly, the power of roots is 5. And what was the numerator? Is power of variable, or x power of 1, or just x. And is 1 over or 3 over y, is x power of 3 over y is equal to y power of roots, and the power of x is 3. And the next one, write in index notation. So the inverse operation of in the first exercise, as here is given just in how can I say, radical numbers, and we need change to index form. So in square root 90 means 90 goes to outside, and what is the power of root is 2, the denominator. What is the power of 90 is 1. The answer is 90 power of 1 over 2. And a cube root 64, in cube root 64, you'll write it 64, and the cube is our denominator, and the power of 64 is 1, so the answer is 64 power of 1 over 3. And the last one, okay, this one is for you. And the last one, in square root x minus 2, the power of root is 5. So x minus 2 is base, and 1 over 5 is our index. So, dealing with the non-unit fractions, sometimes you may have to work with indices that are non-unit fractions. For example, x power of, I cannot see, it's 1 over x, or x power of 2 over 4. To find the rule for working with this, you have to think back to law of indices for raising a power to another power. Look at these examples carefully to see how this works. Okay. Yes, the power of x is 1 over 3, and it means the other words power of power, and x power of 1 over 3 and power of 2. And if you want to open the bracket, you will multiply the powers. So x power of 1 over 3 times 2, and is equal to 2 times 1 is 2, and or 3. And how can write in a radical number? The base is x, and the power of root is 3, and the power of x is our numerator. Okay. In the next lesson, we'll see it again for today. Thank you for your attention, guys.